everyone, I am Dhanush from ECE department. Today I am going to take seminar about DC motors. Topics to discuss: Introduction to DC motors, Principle, Construction, Working, Types and its applications. DC motors. A DC motor or direct current motor converts electrical energy into mechanical energy. A direct current motor is fairly simple electric motor that uses electricity and a magnetic field to produce torque, which turns the rotor and hence give mechanical work. In the slide given, you can see the motor in the below, and above is a motor which is present in die cars. Principle of DC motors. In any electric motor, operation is based on simple electromagnetism. When a current carrying conductor is placed in an external magnetic field, it will experience a force. Example: Lorentz force. Due to this force, torque is produced, which rotates the rotor of motor and hence a motor runs. In the image given, you can see a magnet with a north pole and south pole. If we place a conductor in between the two poles, it experiences a magnetic field due to that two poles. The force may be of a Lorentz force. Due to the force, the rotor rotates and the motor runs. Construction. DC motor consists of two windings: field winding, armature winding. Field winding is stationary and armature winding can rotate freely. Field windings, when a DC supply is given, magnetic field is produced. Armature winding, when connected to DC source, shaft connected to it rotates due to Lorentz force. The image given, you can clearly see the rotor, axle, brushes and commutator. Here is a diagram of a DC motor. Here the center part is a rotor and the outer part is stator. Stator remains constant and the rotor rotates. You can clearly see sun poles, interpole, commutator, armature winding, field winding. Working of DC motor. Types of DC motors. DC motors are of three types. They are DC shunt motor, DC series motor, DC compound motor. First we are going to see about DC shunt motor. In DC shunt motor, the parallel combinations of two windings is connected across a common DC power supply. The resistance of shunt field winding RSH is always higher than that in armature winding. This is because the number of turns for the field winding is more than that of armature winding. The cross-sectional area of wire used for field winding is smaller than that of the wire used for armature winding. In the image given, you can see clearly the armature. It is surrounded with the coils. Above is a circuit diagram. You can see sun field winding RSH. Next, DC compound motor. DC compound motor is of two types: long shunt compound motor, short shunt compound motor, and in that you can see cumulative compound motor, differential compound motor. Before going that, we can see about DC series motor. In DC series motor, the field winding is connected in series with armature. The current I passing through the series winding is same as the armature current. Therefore, the series field winding has fewer turns of thick wire than that shunt field winding. Also, therefore, the field winding will possess a low resistance than armature winding. You can refer the circuit diagram given. In DC compound motor, we are going to see about long shunt compound motor. In this, the series winding is connected in series with the armature winding, and the shunt winding is connected in or in parallel with the armature connection. In short shunt compound motor, the series winding is connected in series to the parallel combination of armature and the shunt winding. This is done to get good starting torque and constant speed characteristics. You can also refer the circuit diagram given. Applications of DC motors. First, we are going to see the applications of DC shunt motor. DC shunt motor is used in lathes, fans, pumps, disc, and a bandsaw driver requiring moderate torque. DC shunt motor is used in applications which requires moderate torques only. In DC series motor, it is used in electric traction, high-speed tools, etc. DC compound motor, it is used in rolling motor mills and other loads requiring large moment of torque. Cumulative compound DC motors. If the two field windings, example series and shunts, are wounded in such a way that the flux produced by them aid or assist each other. It's a explanation of cumulative compound DC motors. And if in case of differential compound DC motors, if the two field windings, example series and shunts, are wounded in such a way that the flux produced by them always try to oppose and try to cancel each other. Thank you. If you have any doubts, you can ask me via email. Thank you.